Right, it's being recorded. Daniel, if you're saying anything, you're muted.
Excellent start. Hi, everyone. My name is Dan. I think I've met, thank you, Roman. I think I've met everyone here, except for maybe Jessica. Today I'm on the core engineering team here at Trust Machines, and I've been working on sBTC. Today we're going to go through kind of like, um, an overview and also dig deep on some parts of the sBTC project, both from how we um, develop the software to high level overview of how it's all supposed to work, and low level, like how do we work as a team. I'm going to go ahead and share my screen. There are a couple of things I want to share with you all for this presentation, and then the question I have is where to start. Actually, no, I know the answer to that. Here we go. So I'm going to share this with you all. It's a document that Ashton was so kind to put together. Yeah, sure, share. Share anyway. All right. So so this is basically the rough outline of how this meeting is supposed to go. First, I want to start off with a high level of like how sBTC is architected from a high level, and it'll help kind of focus where put some color on the code if we dig into there. So it would be great that the 0.0 here above is the high level architectural overview. There's a link to an Excalidraw diagram. So I'm going to start there. I'm going to share my screen just in case you don't feel like doing that. Hold on one second. This is the one. All right. I wonder if you guys can see that well.
I can see it.
Perfect. All right. So yeah, sorry, there's a lot of stuff here. I don't like busy diagrams, but just to get a high level of what's going on here. So the right sBTC, it's a token, but it's also what we're building is a bridge. These are the core components to sBTC and how it's supposed to work. At the center of it all is the signer application. That's where most of the complexity lives. But there are a few other components here that are noteworthy, some of which actually I've left out of this diagram because I felt it would be too busy. Right. There are two main applications that you need running in order for a signer, in order for the signer application in order to work correctly. We need Stacks Core, and we need Bitcoin Core. Naturally, that's what you would expect, given that this is a bridge from Bitcoin into Stacks. And outside of that, we have this Emily API that we need in order to receive deposit requests into sBTC. It's kind of like the backend component for how users will interact with the bridge application itself. So when they want to go and make a deposit, they go to some front end that front end will need to communicate with the Emily API. After they make a deposit, the signers don't get notified of it automatically. They will reach out to the Emily API to get any deposit requests that haven't been fulfilled already. And when they get those deposit requests, they validate it, do the same validation that the Emily API does, because we're actually going to be sharing the same code base, but each of the signers will validate it independently. And when they get that deposit request, they share it amongst themselves. And then also they store it in there. Well, actually, there's another critical point. They vote on it. They vote on whether they're going to accept the deposit request. And after that, they store all that information, raw deposit requests, as well as all the votes of all the signers. And they store that into their database. The other thing to note of note here is that they're internal to the signer application. There's a number of different processes that are ongoing. We have Bitcoin Core listener, and some of these are also redundant, just on purpose. So we have a Bitcoin Core listener where we listen for incoming Bitcoin blocks. That kind of drives the whole process forward. Whenever there's a new block, we need to take some action. Either update our view of the Bitcoin blockchain in case it was a reorg, or we know we can finally actually service a withdrawal request or something like that. We have another process for listening for events from Stacks Core. That's a really important part of this. I mean, they all are really important, but I think it's subtly extra important, the Stacks Core Event Observer. So when a user wants to initiate a withdrawal, not pictured here, but when they want to initiate a withdrawal, they can go to the Emily API, or they can, on their own, construct a Stacks transaction somehow and submit it to the Stacks blockchain. When that request is confirmed and an event is emitted, then the signers will get that information and be able to act on it. They don't get the event, then they can't act on it. But anyway, so that's the critical part that I wanted to highlight. Let me just pause here. Is this too low level or just fine for those of you? All right. Right. Okay. And all right, so we have those two event observers watching the different blockchains and looking for events. They act on it when there's a new Bitcoin block or what have you. The other different important processes within the signer application is the coordinator and the transaction signer. Those processes, they kind of, well, the latter one does what you think it does, kind of, right? Right here, we have shown one signer application, but we know that there's a collection of them run by different entities. And whenever they want to sign either a Stacks or Bitcoin transaction, they need to work together to form a signature. That whole process is done using an algorithm that was kind of designed in-house. It's a modification of a well-known algorithm for constructing thresholded signatures. That's the formal name for it, but basically for constructing signatures in a distributed way, we use a modified version of a well-known algorithm. The transaction signer is responsible for following that algorithm. It does validation throughout the whole process, and we have multiple layers of security for making sure that things are done correctly. Messages are already encrypted. between the two at the communication layer. And then when you get a message, you validate that it's from the right person. You form a signature, and then when you form a signature, you broadcast it to the respective blockchain that's supposed to be broadcasted to. The coordinator is a really special process within the whole thing. So I mentioned before that we have this, we have here a picture of one signer application. There's many of them. Only one is the leader at one point in time, and we use the word coordinator for the word leader. The coordinator is the one that's responsible for actually gathering all the signatures, initiating or submitting the actual transaction. The coordinator is selected randomly, and by the same random process, we use the Bitcoin block hash to, essentially we use as an input to the randomness, we use the Bitcoin block hash to figure out which of the signers that we know about is the actual signer that's going to be the coordinator right now. And that's the one that's responsible for, like I said, managing, making sure that they are the ones that are constructing the transactions that need to be constructed, following up on any work that hasn't been completed by the previous coordinator, and essentially managing the whole thing. So let me just pause right there. I think we're all relatively familiar with this to varying degrees, but before I go, anybody have any questions so far about this? Solid. I'm killing it. All right. All right. All right. So high level overview done. Next part is a repository overview. So let's bring it up.
A quick question, actually.
Yep.
On the Emily API. Is the Emily API intended to be the de facto only way to interact with deposit and withdrawal requests, or is it possible for somebody to write their own Emily, for example, for their app?
That's a really good question. So the design for V1 is very tied to the specific Emily API that we're developing in the repo right now. Yeah, we don't. I don't even think we have a config really for it. We definitely don't even have a config for it. But I think once we add that in, it will. I think we might be able to easily have anyone run their own kind of Emily, application. Like that will be simple as long as you abide by the same API. It'll be fine. But
can I add a quick detail?
Yes. Yeah.
So the Emily API gets around the issue that we had with deposits, where the deposit is done with a Taproot script. So unless we're adding a bunch of other information, the signers themselves don't know what is a deposit and what isn't just by looking at the Bitcoin transactions. So it starts off with just being the resource through which these signers know what's a deposit and what isn't. So it uses the Emily API endpoint to list pending deposits in order to know what deposits are pending. In future versions where the signer set is more decentralized, then it can easily be set so that it's receiving deposits from another endpoint. But because we're looking at a restricted set in this first iteration, we're giving them that API for them to be getting the deposits from. That said, in order to make the deposit, you still need to make a Bitcoin transaction, and then you just need to notify this API service. So I guess kind of the long-winded answer is, fairly trivially, if people can create their own ways to notify what deposits have been made. But in the V1 version, we're looking at a single one. Does that make sense?
Yeah, cool. Thanks.
Yeah. As an aside, I think during V2, don't we also want to allow like support another, like instead of commit reveal, some other way of making a deposit? I forget if we're actually going to aim for that for V2.
That's going to be a discussion with the MVP requirements for the V2. But the current intention is that the two avenues would be make the deposit on Bitcoin and notify via an API, or make a notification on the Stacks layer, which would then incur a fee, right?
Gotcha. That makes sense. Okay. So where were we? Just make sure. All right. So repository structure and so on. So I mentioned before that there are a number of different applications. They all live, number of applications that we're building or have been built. They all live here. All the different components. I'll just start from the top. There's the blocklist client. So under the hood, the signers use that, or can choose to use that to decide whether or not they want to accept or reject any particular deposit request. So depending on the jurisdiction that they're operating under, they might be required to block certain transactions. And we have a blocklist client that they can use to run and answer their help them answer that for them. We have ours, a big component to sBTC is the smart contracts. That lives, you know what? I'm going to switch over to using this, sharing a different screen. Hold on one second. There we go. All right. So what do I want to bring up? Okay, over here. On the left-hand side is where all the different folders that we were looking at before. We have our contracts over here under the contracts folder. So these smart contracts, the Clarity smart contracts, they're integral to the whole flow naturally. They are the actual parts that emit the events that are necessary for the signers to get the information that they need, and they are also the ones that record, that do the minting and all the other, like, the core basic stuff that you would expect from a bridge. And just moving on, we have dev m folder. That's where we have so as we get closer and closer to being able to release on testnet, or even while we're on testnet, we need something to make sure that that we can spin up and run all the different components locally to see how things actually work. One of the goals that we wanted here for the dev-env environments is to actually run a suite of integration tests, either in the cloud or locally, perhaps ideally as part of CI. But this folder here has basically all the different containers that are necessary to run the full suite of applications that we've developed, as well as the ones that are necessary to run the signer. Emily, this is where the Emily API code lives. We have a protobufs folder. It's really sparse. I think we need to update some stuff eventually here. It's for how the signers are going to be communicating with one another. And we have a library that we use on the signer side as well as on the Emily side. Eventually, I think we need to add that in. for doing validation of any deposit requests. So if what users do is they say, hey, look, I submitted a transaction, it's here, right? And they tell us that it includes this information, right? Or maybe they don't even tell us, but what we need to be able to do is take the raw Bitcoin transaction and oh no, they definitely need to tell us. Also, they need to tell us what it says, and we need to say, oh, okay, yeah, this is exactly you haven't lied to us. This matches what is in the transaction actually, and it is something that we are interested in, using as this is a valid deposit request. So most of the core code for doing that kind of validation is in the sBTC crate here. It's a really small crate, but really important. And then the main area that I spend most of my time is in this signer folder here, in the signer crate. It includes the migrations for setting up the database, an example code for an older example code we actually need to update it, and as well as a bunch of different source code that I'm not going to go into, unless you really, really want to see some code during your spare time or during this meeting, which I highly doubt. And then we have some integration tests here. I do want to highlight. Actually, this is not part. It's not important. I was going to highlight that we have a few integration tests for interacting with Stacks, but many of our Stacks related integration tests don't run in CI, because Nakamoto is actually quite difficult to run in CI. But it's definitely a goal of ours to actually run it. All right. Any questions? All right. Other window. Actually, no. I'm going to go back to the same one because I think most of this stuff is the same. Excuse me. Hold on. Okay. So, right. So let me just take a step back. So the next few parts of things that I wanted to talk about for the rundown of the sBTC are kind of like getting started, how we actually submit code, stuff like that. And kind of like, so that people kind of understand exactly how we develop. We have this README here that I think we try to keep very up to date about what's going on, how you can get started, what's necessary in order to do any development. So, we have a code of conduct that's accurate. We have what you need to install with installation instructions. We tell you what's supported as far as a development environment. We only target Unix-based operating systems. And when it comes to contributing, like, so if you were now, whether you're inside of the Stacks ecosystem or outside, we provide a couple of things to make it really easy for you to get up and started. One of the things which I really need to thank Joey for pushing is we have a Docker file for anyone who wants to kind of like just get started without thrashing their machine with all the installed stuff that you would need in order to work. So we have a Docker file that's in the root of the repository. And we provide we provide a make file with all these commands to help you get started and develop. We also provide make files for make commands, for launching a local DevNet. So if you wanted to get started to spin everything up and see how things work, we have a few commands to help you do that. And yeah, that's about it. So far so good. All right, let's keep chugging. All right, so actually submitting, thank you. Actually submitting code. We don't do anything particularly special when it comes to submitting code. If you want to submit, some change or, do some unit of work, you basically just make a branch off of the main branch and you open a PR, merging it into main. Typically, we have about like every PR, not typically, but some of the time, a non-trivial portion of the time, when you open a PR, it's usually linked to a particular ticket, and it usually closes that ticket. I shouldn't say usually. We're really flexible, but we aim to have it one PR, one ticket. As far as like dependencies, right? So I think this part's pretty important. We try to only use really reputable dependencies. These are the dependencies for the signer. Actually, this is for the whole project, but generally speaking, most of these are used in the signer. So for any of our dependencies, if there's a new one, I'll generally take a few moments to kind of vet the dependency. I look at the author of it. If it's like a well-known one, I'll usually be able to recognize it. If it's not well-known, I'll actually look through the code a little bit, look through its dependencies as well, to get a sense for, okay, like what's really going on here. Is this, there's been some scam crates that have popped up within the last, I think within the last year. I want to say within the last year, as in like the Rust blog posted about a few of them on crates.io. And so I generally try to look out for anything that's suspicious. Even misspellings have been commonly used crates. You got to be careful. So anyway, we use Cargo for that. We also have I'm jumping ahead a little bit here when I'm talking about security, but we have a Dependabot that does security, that posts any security advisories onto the repo if something comes up that's an issue. And so, yeah, we try to be on top of any security things that can crop up. On the Clarity side, a lot of the development is, let me just take a step back. Besides Rust, we have Clarity code, and the Clarity code is often tested using Node, using TypeScript. So we use p-npm for managing Node dependencies. There might be some other reason why we have Node dependencies as well, but I forget. For generating OpenAPI specs.
And the AWS CDK, definitely.
Right. That's right. So yeah, we use it for a few things, but not for much of the core code. Mostly it's Rust and Clarity for the core things that users will interact with or that will ship. Right. So next thing I want to talk about is a little bit about testing, quality assurance. So as I've mentioned before, most of our stuff is built in Rust. We use the regular Rust test. I want to say Rust test infrastructure, but I really mean just like we use the standard stuff. We use Cargo test, soon to be Cargo next test. Once I ask people if they want to move to that. For integration tests, we spin up Bitcoin Core, Postgres, and this is just to actually run the migrations. So we spin up Bitcoin Core and Postgres and run our tests that are related to Bitcoin Core in CI as part of our regular flow for PRs. We don't do any test coverage. And we also, as far as like quality control, we lint as part of the CI flow. So if you're not for on the Rust side, if your code's like, isn't good according to the linter, then it'll be rejected. We expect developers to also use cargo format. Generally, that's the case, almost always. But sometimes, I forget. Maybe we should enforce it, maybe not. I don't know. I don't particularly care, either one way or the other. But generally, yeah, we try to make sure we have high quality code here. And all right, I'm going to skip over CI/CD. That's the next thing I wanted to talk about, but I basically already did. So the next thing that I wanted to talk about is how we work, right? So a couple of things. It's not just the code, but there are a couple of things we want to do when we're working. So obviously we want working code. We want to have it well tested, but we also want to have documentation for our code. And we also want to make sure that, so we have documentation both at the design level as well as at the code level. So for example, here's an example where we have lots of, maybe not a lot in this one, but we have some documentation here to let the reader know what's going on. One that has a lot, this one has a lot, maybe too much. So let the people know what's going on, right? This is what's going on. This is the format to expect. This is why things are done a certain way. So like there's a lot of documentation in our code base to let everyone know what's going on. At the design level, so I'm going to switch to a different thing that I'm presenting. All right. All right. We have we have most of our so our whole design process was pretty open. So we have tickets for all the design parts of sBTC, right? So, and as well as like links to the actual docs themselves. So for example, for the withdrawal flow, we have the Clarity design doc here, going through exactly what we were expecting things to do. By and large, we've been abiding by the design that we've laid out well ahead of time in the actual code. And that's how we end up reviewing things against what was designed. If we deviate, usually we have to have a really good reason. Okay, why doesn't it want to go back? Okay. All right. So yeah, if you want to know, so just to take a step back, I wanted to show you guys that we have like, hey, look, we have designs, we have comments, we have documentation about what are the things supposed to do, how things are supposed to flow in the code, why things are done a certain way. And to find these designs, something that we need to fix in the future, you kind of just go to the issues tab and search design. That's what I generally do. And I scroll down until I see one that's prefixed with design. And that's generally how you find the designs of how things are supposed to go. we also have the same ones for like when we were designing, we did research on the various questions. So most of the time, if you have a question about how, something that's come up, like, hey, look, how are people going to pay for the transactions? How the signer is going to pay for the transactions? We talk about sponsorship. We had low-level designs for how those things are supposed to work. And sometimes, like me, for the sponsorship, I'd forgotten that we probably have pretty good documentation on what's supposed to happen here and why. So yeah. Right now I'm here, but oops. Another thing about, so I spoke a lot about security and permissions and so on. I mentioned that we have a dependent bot that comes through and looks for vulnerabilities. I generally look through our dependencies to make sure that they're legit. Usually I lean on reputation. So if I know the developer, like, oh, they're on the core Rust libs team, I usually give it a pass. And I'm like, oh, this is probably like really good. I'm not even gonna check. But maybe one day we'll add in some code security scanning or something. We could, but yeah, we don't do it right now. There are no security credentials in our repository. Like none. There's like a clearly bad key in our testing code. Like it's clearly not a good key. But besides that, I think we do a pretty good job with security. Oh, another thing, access control. So if you wanted to merge a PR, make some code change, I think only those who are added to the proper teams can actually make any of those changes. Anyone can submit a PR, but obviously we're not going to merge any OPR. And I mentioned this about documentation. I did not mention one other thing. So we require all public functions and all public structures in our Rust codebase to have documentation. So if you create an object for whatever reason, if it's public, you have to describe what's going on. And generally, I do this for ones that aren't public as well. But yeah, describe all the fields as well as what it's supposed to do and why. And that's basically it. Last one. Team communication. Probably the most important thing here. How do we all work together? Generally speaking, we talk with each other on Slack. But for a lot of the discussion, we also have those things in the tickets in the GitHub issues themselves. So if people want to know why we did a certain thing, why we went a certain way, it's really easy if we have these things out in public. It's supposed to be a public thing anyway. So sometimes the conversation will happen in the GitHub issues themselves. And also we have every other day, we have stand up about sBTC, where we go over any questions that people have, go over what work is outstanding, what work we submitted. Also, just to talk through some things. Oftentimes you might, you get that context by talking to actual people. So besides like any one-off conversations, we have our stand up every other day. We used to have it every day or something like that, right, Ashton? But we've since moved over to having it every other day. Yeah, that's roughly it. I spoke a lot. Let me stop again to ask if anyone has any questions, comments, concerns, or just talk about life.
Yeah, I I have a few questions about the code base. I guess the first one would be, what are currently the biggest construction sites in the code base? So essentially the maturity of the different components. What is kind of already ready in a good state and what is still kind of quite in flight?
Good question. Let me go switch over. 1 second. Okay. So, right. So this is my VS Code. Most of these are pretty settled, with the exception. There's a few exceptions here. I have a PR in flight for this. So most of the things in this Bitcoin folder are more or less settled. And I mentioned an exception of things that are in flight. So this function here will change. And there's another one that has a to do in it that will also change. And there's a PR that's, I think it's been recently approved, that also modifies this file. So within a day or two, no, by the end of this week, this file will be largely done, and this folder will be largely done. On the Stack side, there's quite a bit in flight. I think you pointed this out as well earlier today in the channel. Most of this is stable, but we have to do a lot of validation of the request. When a signer asks another signer to sign a transaction, a Stacks transaction, that will get done basically here in this kind of validate function. I'm not actually thrilled about the API here, but generally speaking, we're going to have something that says validate me. I think you saw that a lot of this stuff is to do. Besides the validation stuff, most of it is, oh crap. No, yeah, this is like a lot of stuff that's in flight. We're going to also change the API for some of the accept deposit, complete deposit. This is going to change. What else? Okay, so what else is stable?
The Clarity contracts as well are
Clarity contracts are stable, but trying to think within the signer code base, what's best to look at next. Maybe this wallet right here, it's pretty stable. This wallet module in the Stacks folder. This events one is pretty stable as well. The only reason why it would change is if the Clarity smart contract changed, and I think you guys pointed out a few things that would make us want to change them. And there's also a PR in flight to change one of them, so that's might change the events that are admitted. It's not a very satisfying answer, but essentially not a lot is stable at the moment. There are lots of there are not a lot of files that are stable, I should say. Lots of code is not going to change. But along the edges, as we build in more functionality, quite a bit is going to change. This keys module is not going to change much. We might add some functionality, but we're not going to modify it very much. Same thing for the signatures module, probably. I think that's about it. Sorry. Oh, and the sBTC crate is probably pretty stable. I think it's pretty stable. Like if it changes, it's going to change in a very trivial way. Any other questions?
Thank you. I have many more, but I want to leave space for others to ask questions. If there are any other questions, I guess. So since there don't seem to be any.
Yeah.
So what more I had is like, what are some of the biggest deviations from the design documents that you have? Maybe there are some components that completely deviate from the design. You said that should be the exception, but maybe you have like some larger cases.
That is a good question. Where have we deviated from the design? So I can think of a few where I know we're deviating from the design, but for good reason. So I know we're updating the smart contract now to one of the smart contracts now to allow for faster deposits. So this complete deposit wrapper interface will change. It's going to take 2 more parameters. And the event emitted here will probably change too. The PR doesn't have that event emitting change, but I'm going to ask to have it in. What else will change? We, in some of our design, like some trivial things change. Like for example, in our design, we, let me reorient things and let me show, it might be best to show. So hold on 1 second. Hold on. Okay. Okay. Right. So our designs talk about recording data on chain, on the Bitcoin blockchain, about how the signers voted, how many deposits. There's this op byte that is proposed to be B, and there's these magic bytes that this has to do with sBTC. So the proposed design has an op return UTXO that looks like this. I'm proposing it looks like this in a PR that I just created. I also changed the meaning of this byte. None of those things are critical. This is just for extra validation that allows us to validate that the signers are doing what they're supposed to be doing if we have the requisite information. And this allows us to change the format in the future. Besides that, oh, right, there's another area. So how the signers are communicated. This is a big one. So hold on. So the original design, oh, it's been merged. The original design had the signers communicating over a relay node. And so essentially what you would do is one of the signers would just establish a connection with some centrally hosted relay node. They would send their messages to that node, and that would relay it to all the other signers. But we deviated from that plan and instead have the signers communicate peer-to-peer using basically using a protocol that's built up using libp2p. So that's a big deviation. But what else is there? Oh yes, there's more. These are important. I think the original design had a few more architectural components. So I have here, this has, right, 2 services, a total of 4, right? Services outside of the signer. And I'm missing one with the blocklist client. But generally speaking, it's relatively like the necessary pieces. And maybe we can even get rid of the database being an external thing. But the original design had us using the Stacks API, as well as Electrum server, and maybe a third thing, as well as these like different components that are necessary in order to operate the signer. But those requirements have been removed. I think we still have them in DevNet, and so that we can actually see, inspect the system as it's running. You need kind of like the Stacks API to kind of see to run Explorer, to have a UI so you can see things, but you don't need it to run the signer binary. So I think we removed those requirements. And is there anything else? I can't recall. I don't think so. It might be really trivial, or accidental. But yeah, big ones. We reduced the number of things that's necessary in order to have a working signer. And we changed some things about the format of the data that's stored on chain, on the Bitcoin blockchain. We're making some changes to the Clarity contracts. One of them is because of something that you guys pointed out to us. So we already have a PR out fixing that, and we're making another change to allow for faster deposits, which was necessary, but before it was a blind spot of ours. We didn't realize that we were introducing, we were going to make a mistake, and then we realized that we don't want that, so we changed it. Really good question. The original design did not have us listening to Bitcoin Core over Zierra MQ. It was actually left ambiguous. We knew it was an option, but we didn't settle on it. And yeah, that doesn't count, but yeah, nothing else.
This is awesome. Thank you so much. And I guess one last question that I have from my side is just the different storage types that you use. For example, for the deposit requests, we've seen that you can create deposits over Emily API, and also there's a block observer that runs over the new Bitcoin blocks, right? And we've seen that there are at least 2 different representations where you keep track of the deposit requests. So if you could just comment on that, that would be super helpful.
That is I think I know what you're referring to. Actually, Ashton, go ahead.
So there are 2 different components here. There's one that's the deposit API, which is really meant to be a pretty raw public-facing artifact. So someone makes a deposit there, it tracks it, and then the public-facing interface is updated by the signer. But then each individual signer, we don't want it to be simply tied to this API, because each one of them has their own idea of the Stacks state and its Bitcoin state. These are decentralized artifacts, which are different from this single AWS DynamoDB artifact. So we have those represented in 2 separate places because they're parts of different entities with different consistency constraints. Does that make sense?
Yeah, that makes sense. I guess it's just something that we need to take a closer look at, because if you have like 2 different states, you need to kind of be careful to process them correctly, right? Like this can introduce some problems.
Do you happen to know which files you're referring to that have the 2 ones?
Yes, I think it's the block observer RS. But we are almost out of time, so this will take a few more minutes to go through.
I see. There's a block observer where we get deposits, and then there's something else you were saying. Some other place. Yeah,
I think it also talks to the deposit RS file. So there's like a loop which iterates over new blocks, and then it fetches like new deposits from the Emily API, as well as it has some functions to process transactions directly from the new Bitcoin blocks. And then it writes to Bitcoin storage and separately to deposit requests. So there's like two places where deposits are being kept.
Got it. I'll look through to see if to see exactly what you're referring to and come up with an intelligent answer to that. It could be one of three things. One, like what Ashton was saying, we have different clients that do different things and so on. But it could also very well be that just a slightly different flow, like it's just not done or something like that. Off the top of my head, yeah, I don't have a good answer. I'll have to go look and I'll get back to you. Actually, I'll ping you after this because we're at time. But yeah. All right, this has been a blast. I hope for everyone. I've had some fun. Thanks. Oh, so yeah, I hope everyone has a lovely rest of their day. I know it's pretty late for a number of you, for like 50% of you or something like that. So more than 50%. I'm like the only one that's like, it was like early in the day.
All right. Thank you, Daniel. That was a great presentation.
Thanks.
I guess your day.
Bye.